Alright, this is College Algebra, Unit 4, Expressions, Equations, and Functions. The next page of our notes deals with linear regression. This is a graphing calculator reference sheet on how to create a linear regression equation for given data. So this is an example which you're welcome to go through. One thing I would add is to store the regression equation in this portion of the reference sheet. It doesn't include how to do that. So the keystrokes for that are vars, y vars, function, y1. So you're going to hit stat calc 4, double check to make sure your L1 and L2 are your X list and Y list respectively. Then scroll down to store reg EQ vars, y vars, that's this button. Then scroll to the right, function y1. Then hit enter, enter, and it will give you the equation that goes through the data. To view your graph, you hit, well, first you have to turn your stat plot on, so second stat plot, turn that on, then hit graph, I beg your pardon, hit zoom 9. Now you can see your points and you can see your linear regression equation because it has stored it into y1. So you're welcome to look over that. Let's take a look at some examples here. So we're going to examine some techniques of showing how Fahrenheit measurements are related to Celsius measurements. One method is to create a table listing Celsius measurements corresponding to Fahrenheit measurement. We call these measurements in this table, we call that data. So we're to define these values as ordered pairs. We are going to let Celsius be our X values, Fahrenheit be our Y values. So then these become ordered pairs of -20, -4, -10, 14, 0, 32, 10, 50, 20, 68, 30, 86, 40, 104. Okay, this is indeed a function. There are no repeating X values. As such, this function is a discrete function because they are unconnected points. However, what we're going to do is make this discrete function have connected points, which is really valuable to create a model like this because then you can fill in data in between that you don't have or data that goes beyond the X values, either on the left or on the right. So it's really helpful to create models for this kind of data. So we're going to go to our home screen. Please hit stat, and then we're going to edit. Anything that you have in L1 and L2, go ahead and clear by highlighting the list, hit clear, and then enter. Highlight L1, hit clear, and enter. Do not hit delete. If you hit delete, you will delete the entire list, and then your calculator has to be reset. All right, so now we're going to enter the X values for Celsius into L1. The way you do that is you hit -20 and then enter, -10 enter, 0 enter, 10 enter, 20 enter, 30 enter, 40 enter, okay, until you have the right number of values. Then scroll up or to the left for L2, and we'll put the values of Fahrenheit in L2, -1 enter, 14, enter. 32, enter. 50, enter. 68, enter. 86, enter. 104, enter. One thing you want to double check is make sure that your two lists are even. Now hit second quit so that you're back on your home screen. Okay, we want to turn our stat plot on. You can do this in one of two ways. You can hit Y equals and scroll up and make sure plot 1 is highlighted, or you can hit second stat plot, get into the stat plot, and just make sure that on is highlighted. Another thing you want to double check is to make sure that the X list is L1 and the Y list is L2. Now hit second quit. Then we're going to hit vars, Y vars, no, excuse me, second quit. Stat, calc, 4 for linear regression. Now we hit vars, Y vars, function, Y1. This is the linear regression. So y is equal to, our a is 1.8, x plus 32, okay? This is our function with Fahrenheit as our y and Celsius as our x. Now let's take a look at this graph. Your stat plot is on, so you're going to hit zoom and 9 for zoom stat, and it creates the window automatically for you. So now you can do lots of great things like get to the stuff that's in between the data. One thing I do want to mention before I move forward is sometimes people's calculators don't look like mine, and so when you hit stat, calc, linreg, then you just get it, your screen just looks like this, okay? The way you can then make sure that you get the equation is you have to tell it to draw from L1, so that's second 1 for L1, then you have to put a comma, then second 2 for L2, then vars, y vars, function 1. So if you have a TI-83 or if you have a TI-84 plus but not the CE edition, then your calculator will likely look like this, and then you can just hit enter and you'll get the exact same equation. All right, let's take a look at the graph from this. Now we have a continuous function with a domain from -infinity to infinity, a range from -infinity to infinity, and we can do stuff like find out what is the temperature in Fahrenheit when Celsius is 33 degrees. The way we do that is, again, Celsius was our independent variable, so we were plugging that in for x. We hit second, calc, value, hit 33 for x, and it tells us that the Fahrenheit corresponding temperature is 91.4. Okay, if you want to take a moment to graph that on the side, you're welcome to. Now consider the following table. This can be found in page 18 of our textbook. It illustrates the number of drinks resulting from blood alcohol percent for a 90-pound woman. The drinks represent one 12-ounce beer. So we're going to create a scatter plot, hit stat, edit, clear out your Fahrenheit and Celsius data, and we're going to let the number of drinks be our x, so that's what's going to get put in L1, and then our blood alcohol percent for this 90-pound woman is going to be L2. So 0, 1, 2, 3, 4, 5, 6, then 0, 0.05, 0.10, 0.15, 0.20, 0.25, 0.30. All right, now hit Stat, Calc, Lin Reg, store it into Y1, okay, and this is our equation. Y is equal to 0.05 x plus 0, which we actually don't need, so we can just write 0.5x. So, and this is great because honestly, we can't keep giving a 90-pound woman more and more beer in order to figure out what her blood alcohol level would be. So it's important for us to make a model because really honestly, like if your blood alcohol level is 0.3, you're really drunk, and so that's just inhumane to do that to somebody. So we need to create a model in order to figure out data that you couldn't normally get. So what is the blood alcohol level for her if she were to have 7 drinks? Well, now we can look at our graph. Okay, I have to hit zoom 9. So here's our new graph. Okay, look at your window. It has to at least reach 7 or it won't tell you the answer. So we're gonna let our X max be 8. Okay, now I'm gonna hit second, calc value 7. Her blood alcohol level would be 0.35. Okay, how many drinks would make her BAP be 0.08? So I chose that number because it's the legal drinking level for driving. So this value falls in between 1 and 2, but we want to know what would be the number of drinks. So we're going to let y1 be our function. We're going to let y2 be 0.08. Okay, now we're going to graph these two things and see where they cross. Second, calc, intersect, enter, 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 and the x value is 1.6. So she could drink 1.6 beers and her blood alcohol level would be 0.08.